Today we're going to learn about L'Hopital's rule. Now L'Hopital was a mathematician who lived from 1661 to 1704, and he published what he called L'Hopital's rule. But it's generally believed that Johann Bernoulli was actually responsible for discovering and then proving the rule. So let's just get straight to it. L'Hopital's rule says that if we have a limit as x approaches c of f of x over g of x, and that limit produces an indeterminate form, then that limit is actually equal to the limit, still as x approaches c, of f prime of x over g prime of x. So let's look back at some limits that we studied earlier in the year. For example, the limit as x goes to infinity of 5x squared plus 3 over 3x squared plus 7. The way we evaluated this limit was we divided each term by the largest powered x in the denominator. We knew that this goes to 0, this goes to 0, so we're left with the constants, which would be 5 over 3. We also learned in pre-calc that when the degrees are equal in a rational function, that the horizontal asymptote will be y equals the ratio of the leading coefficients, and we know that the definition of a horizontal asymptote is really the limit. So this limit is 5/3, but we're going to look at it again thinking about what's happening with the numerator and the denominator. So as x gets really large, as x goes to infinity, 5x squared plus 3, that entire numerator is going to infinity. And again, as x gets very large, 3x squared plus 7 is also getting very large. So that entire denominator is going towards infinity. So this limit here is of an indeterminate form, infinity over infinity. When that happens, we can use L'Hopital's rule, which says that we can take the limit by finding the derivative of the numerator over the derivative of the denominator. That wouldn't be 3x, no. That would be 6x. But what happens in this case when we look at this limit is 10x, as x gets really big, this is still going to infinity. 6x is still going to infinity. So we still have this indeterminate form, so we can use L'Hopital's rule again. And then the derivative of 10x is 10. The derivative of 6x is 6. The limit as x goes to infinity of a constant is just the constant, and that reduces to 5/3. Now you may argue in this case that it's just much easier to notice that the degrees are equal so that we just use the ratio of the leading coefficients for the limit. But there are some limits where you'll be really happy that you learned about L'Hopital's rule. For example, let's take a look at the limit as x approaches 0 of the sine of 3x over the sine of x. Now if we try to substitute, we get the sine of 0 over the sine of 0, and the sine of 0 is 0. So our numerator is going to 0, our denominator is going to 0, which means that we have an indeterminate form. So we can use L'Hopital's rule. So the limit as x goes to 0, we'll take the derivative of the sine of 3x, which is 3 cos 3x. The derivative of sine x is cos x. And now let's see what happens when we evaluate. We'll have 3 cos of 3 times 0 over the cosine of 0. Well, 3 times 0 is 0, and the cosine of 0 is just 1. So 3 times 1 over 1 is 3. But be careful to check before you use L'Hopital's rule, and make sure that you get an indeterminate form. So let's say instead this limit was over cosine x instead. Well, our numerator is still going to 0, but the cos of 0 is 1. This is not an indeterminate form, so L'Hopital's rule does not apply here.